Okay, hello everybody. Welcome to today's Greytech BIM Up session. And today's session will be focusing around concrete design. So today's session is called Concrete Design Made Simple with Advanced Design. So I'm Jamil Dida, and I'll be presenting today's BIM Up session to you. And I am the Solutions Technical Specialist here at Greytech for our Simulate products. So let's have a look at the summary of what we have planned today. So we have four key sort of things to get through today. To start with, I will show you the analysis of a concrete structure. So it's a concrete frame structure in advanced design. I'll take you through the analysis, the FEM results, and also the detailed results on the concrete members. We'll then move on to designing and specifying reinforced concrete for those particular members. So that can be the concrete beams, concrete columns, and also the concrete slabs. From those specifications, then after we've specified the reinforcement, we can then take that to the next level by being able to generate the reinforcement drawings which show the layouts and the location of the rebar that's needed for that particular element, along with a set of reports to accompany the calculations. Finally, once I've finished the demonstration of advanced design, I will open up a Q&A session where you have the opportunity to ask any questions. So near the end, or as you're going along, please post any questions in the Q&A pane if you have any, and I'll pick those up towards the end. Okay, so time now to take a look at this concrete frame structure in advanced design. So to start with, so here's our model. We need to define our settings. So we will define our reinforced design settings. It's very easy to select members here and filter them, and also choose the right members. So on the right hand side of the properties here, you can see we've made it very easy for you to access these properties. So it's all in one place. And here is where you would define your concrete parameters. So your cover, the type of checks you want to carry out for the design. So that could be your shear force, your cracking, also your buckling. So all of these design settings are found here. So I'll just zoom in here in a second so you can see these a little bit better. Okay, so here we are. The concrete design. Okay, so ductility class, all your class A, B, or C's. Then we've got our concrete cover. So you can define your cover here. You can also change these settings for the cover and the ductility class. These settings can be changed from within the design module as well. So the crack width is very important. At the moment, it's set to an automatic 0.3, but you can impose a value on this. So what it will make sure is you can also enable the correction of the cracking. So that makes sure that that the crack widths aren't exceeded. So they don't go over that 0.3 millimeters. You'll automatically adjust that reinforcement to make sure that the crack widths stop at 0.3 millimeters. You also have option for fire verification, and you can see some settings here for your reinforcement modification, a rib design. So sometimes if you want to design a slab and you have a downstack beam, and you want to consider a rib sometimes, that can give you very accurate analysis, so you can use the rib design for that. We also have some buckling lengths and also a punching shear verification. So back over to the main model now. So these are the settings we looked at for the beam. You can also obviously define the settings for your columns and your slabs as well. So time to head over now onto the analysis settings. So here for the analysis settings or the design settings, you can see a series of settings here. So these are the settings for the calculation as a whole, what that calculation sequence looks like, what that involves. So you've got your creep and shrinkage there, your number of bars and maximum diameters, column calculation. Okay, so we have also got the reinforcement, the stock lengths, what to include in the calculation, and also fabrics. The calculation sequence, again, you get to choose what that sequence looks like. So we also have the capacity design that you can see on there. So auto design reinforcement for the columns. So what that does is it ensures that if in the event of a structure failing, the columns won't be the first to fail. So make sure the columns have that extra capacity to deal with that. And you can also select the reinforcement joints to be saved as a DXF as well. So time to now open the model with the results. So I've already created an analysis on this model. Now here, I would like to just switch to a view where we can see the outline of the members a little bit easier. And I always like to add a transparent look so we can see a better integration, a smoother representation of the results against the contours of the elements there. For the results, let's have a look on the displacements here. Okay, so we're looking at a ULS combination. So let's pick one of 7. Here we can see a maximum of 9 millimeters. Oh yes, and here we have the animation. Here we can see how that structure is behaving generally with relation to the global axes. You can see the movement in the general direction there as well. And now time for some forces. So you can start with some shear forces there, and the slabs and also the beams. Okay, so you can see maximum around 720 kilonewtons. It's now we can also add values to the result, so we can see the numbers on there. In this case, I want to show just the minimum and maximum, so I'll turn off the intermediate values, just so the drawing is not as busy. Okay, so now from the slider scale, I can choose to increase the size of these minimum maximums. There we go. We can also have a look at some moments now as well. Okay, so we need to make sure we select the same type of result for both planar and linear elements. Okay, so these are the sort of numbers that we're going to be designing our elements for. So they need to be able to obviously resist these forces. What else do we have? So mode. So here is something where you can look at how this I've got modal analysis on the structure, and you can see how it behaves at each mode, each interval relative to the vibration of the frequency. So here I've picked a mode at the start, 0.4 seconds in, and it's about, you can see 2.5 hertz at this point here. Yeah, and you can also see a pulse. So again, it's very handy to have a look at that to see how it's, if you have any vibrating machinery or you need to carry out modal analysis. So now let's have a look at another mode. Okay, so as we make our way down the list of modes, you can see that that frequency is increasing as we get to the ends. Yeah. And I'll now also just have a look at the animation as well. So the animation will show you how it varies at each point. It looks quite distorted there. It always looks worse on the simulation than in real life. Okay, so you can see it's moving along the Y plane there for that mode 20. So now we've frequencies increased, gone up to 21 hertz, and now that movement is predominantly in the Z direction there. Vertical movement there. Mode 28, one of the modes at the end again. Now we're all the way up to 85 hertz. So from the animation, that movement now has made its way down to the columns for that mode. Okay. I'll just pick one or two more so you can see how that differs. Okay, so from the beginning you can see where that movement started off for those beginning nodes. On the right hand side we have our RC design results. So these are the important results that we want. We want to be able to look at those required reinforcement, the provided reinforcement, your deflections and your crack widths. Okay, so before we go to design our members, it's important that we have a look at what these values look like, so we know what we're up against. So the reinforcement in the Y direction I've chosen here for the columns, we're looking at around 225 millimeters squared, and this is the for AZ. Again, this is required AS. Now let's have a look at the slabs. So in conjunction, that is with the columns. So just turn off the columns there. So the slabs, obviously we're expecting more reinforcement. So you can see for the bottom slab, at the moment I think I've got some reinforcement at the top there. You can also see some peak zones. So the bottom slab you can see is 3,500 millimeters square meter. Okay, and on the X direction in the bottom of the slabs, that's what it looks like. I always like to display the mesh with the reinforcement so you can see where those peak zones lie. Now, obviously, we can see peak points here. We also have the option to smooth those values at peak. Okay, so we have an option to smooth those values to make sure that we don't get any outliers and resulting then in over-design reinforcement. So that is something during the modeling phase, is to consider a smooth peak smoothing zone around the column. So here you can see this earlier on this model, I've added some reinforcement to the top two slabs. So the green is the general reinforcement, red area shows the additional that I provided. So in general here you can see that obviously the from floors from the ground floor up to the third floor, the first third, I need to provide reinforcement, yet to provide reinforcement slabs for that. Okay, so now let's have a look at some concrete deflections. There may not be any results with this one because I did enable deflections in the settings for that, yeah, for the beams. Okay, so let's have a look at the slabs. I did enable deflection for that. And here we can see maximum of around 1.7 millimeters, and then on the other side, on the other end is 10.5. So for cracking, crack widths here. Okay, so let's have a look at those crack widths. We're expecting to see that crack width limited to 0.3. So there we go. You can see in any case here, it doesn't exceed that 0.3. Okay, so it's corrected those crack widths to make sure that they don't exceed 0.3. And some design efforts, always important to have a look at what these moments are and what our reinforcement needs to be able to resist. You've also got your concrete and steel stresses there and your capacity design as well. So there we have little bits of the FEM results and the concrete design results. Now let's go ahead and open this column with the design module. So again, you can open this within the integrated design module, or you can launch it from the standalone module. So here I have a column which where the reinforcement's already being calculated. So I'll pick a column which is almost blank. Okay, so it's just geometrically there with the FEM results, but we need to then add reinforcement to that. So let's open a different one. Here we are. So you can see how the three viewports are arranged here. So you've got 3D interactive view. You've also got an elevation with all the forces. So these are the forces which it will be designed for. Okay, 3D interactive view there. Nice feature to have. And also a section, cross section. Then I want to be able to, from the geometry, define my settings. So here it's carried across 300 millimeters from the main model, but I can update that. So I'm just going to increase this to a 400 square. And then let's amend the height. So let's, for example, say 3.5 meters. So again, you get the best of both worlds here. So you've analyzed the model globally, and then you've got individual member design in here. Here's your settings for the buckling length, so you can choose the type of buckling. So in this case, on the left-hand side, you can see that I have a series of members there. Yeah. From there, you can either design individually, or we can choose to group these elements. So then we'll design the worst case in that group. So, for example, we could have the worst case column design if you wanted, or the worst case beam. So here we have the general design assumptions. So your ductility class, your concrete cover, and then also you can change your fire resistance as well. So I'll add in, maybe let's go for an hour. So an hour fire resistance. Okay. Over to the reinforced concrete section. Here we can choose a class. So I might choose to go up to a C3545 here. Ductility class, probably B or C, let's say. And you also get control of your load duration there. Concrete covers. Again, we saw earlier, one of the steps was to define the concrete settings in the parameters and the properties section. Here we can change those settings again if we wanted to. So there are design settings in the geometry. And now for the reinforcement diameters. So it won't consider anything that's H6, 16 or 50 millimeter diameter, as you can see from there. Main reinforcement settings. This is very important to go through this. Yeah? So here you get to choose exactly how that reinforcement looks. So we can add in starter bars as well if we want it, at the top or bottom. At the moment it's looking at general settings for the longitudinal reinforcement. Okay. Wide hooks as well, yeah. So let's have a look at the transversal reinforcement. So minimum diameter, I can go up to 10 millimeters if I wanted, or 8, go back to that, and you get to choose the type of hook as well. You can also define uniform spacing if you wanted, but I've just increased that minimum spacing just for the sake of making some changes here. Uniform spacing, or if not, it will calculate based on a series of packages for the reinforcement along the length of that beam. So now the starter bars, so you have different types of starter bars here. You have main bars, secondary bars as well. So if you're connecting to a slab, it's sometimes important we need to define those starter bars as well. In some cases, we may need shaped starter bars and also top hooks. So you can also choose your lap lengths as well for those starter bars. Okay, transversal bars again for the links to the transverse reinforcement. Okay, so you can provide them in the top or the bottom, or both of those, and also the spacing and diameter. We can choose what that looks like. Again, in some cases, similar to the top starter bars, we've also got the option for bottom starter bars. So I'll change the bottom starter bars. And now I want to have a look at the combinations. So for the combinations here, these are the forces that we are designing against. Okay, so these are the ones we're up against from our main model, top and bottom loads. So it's very important to see where they come from. Okay, so you can see the dead load is given with worst case loads. And now it's very simply a case of calculating. So when I choose to calculate them, I remember it will start off with some reinforcement as a starting point. You can choose to accept this, and from this point then you can amend the reinforcement. So here, if you remember, I selected change to the diameter for the reinforcement. So in this case, it's gone for 20mm bars. So H20s are the main bars. Okay, let's have a look at some of those results now. So what we do, so we can look at the views here as well. So it's important also to be able to visualize what that reinforcement looks like. Yeah, so we know exactly what we specified, whether it's real, and how that's arranged. So you can see very detailed views here. You can see what that lap length looks like. That we might need to increase that. It looks a bit short to me between the additional secondary bars there, just in the top of that column. And these are the stirrups or the links, tying all our bars together. Right, so back over to the views here. We've also got a section view. Okay. Now for the results here, you can see that the longitudinal, the main bars are working very hard, so they are almost close to failure. So we need to, in this case, I'd need to amend those bars to introduce additional reinforcement. Yeah, so the minimum the AS required is still higher than provided in this case. Yeah, so you can see the real is only just over than the required. You can see only by 8mm, so it's very, very close. So ideally, we'd like to probably see this go down to 80%, but I might knock it down just a bit further. So to do that, I can go then into my reinforcement settings. Okay, we can change our settings from there. Or now, if I go into the main bars, okay, here I find some settings for the main reinforcement. So main bars is going for 3 bars in both directions for H20. Okay, I can either change these to 4, or I can provide additional bars. Yeah, so I can provide a secondary bars. Yeah, so we can provide additional 3x3. Yeah, so 3 additional bars in each direction. I'm just going to clear this calculation for this, just so here you can see what that looks like. So let's add in 2 additional bars in those directions, so you can see what that looks like. So you can see what that is what that utilization looks like. Yeah, so 8 H16s plus some 12s gives you a guideline there. So these are the starter bars. So we'll just click OK to that. That's what it's calculated. And that's what it's here. Right, so it's provided, basically now we've gone up from 3x3 to 5 bars by 5 bars. Yeah. So in this case, I'd rather increase the diameter of the bars than increase the number of bars. Okay, so what I can do is go back then to calculate this quickly. We'll just see the results. So restore reinforcement there. Okay. You can always choose restore reinforcement. So if you've made any changes, you can restore it to its original state what it calculated. So you can see longitudinal main reinforcement, main bars. Let's increase this to 4 number H25s. We should see that drop down considerably now. Yeah, that's definitely going to help it. So I click apply. Okay, so we've gone from 3 H20s now to 4 H25s. Maybe over design, perhaps. So here you can see in the results that we're now at a ratio of around 42%. Yeah. So we're looking at provided 3770 millimeter squared against that 1600. So provided more than double what's required there. Interaction curves is an important one as well, to see what that relationship looks like between your moments, all that presented graphically. So if we have a look at the diagram, so here you can see your moments against your shears and your actual forces. Okay. Interactive drawing. So now we want to be able to, we've designed that element. Okay, so we've gone through the reinforcement, and now we want to be able to generate those drawings. So here you can see it generates a sheet, a starting point basically for the sheet. You can rearrange your views on there. Also, you can rescale them to a suitable scale, what works best for you. Okay. And then I'm just going to restore the layout just to go back to the previous view. Okay, here are my sections. So very interested to see what that looks like. So what it's done is the reinforcement drawing's gone back to the 3x3, but I hadn't updated the drawings there. So if you update the drawings, I would see those the 4H25s. So I can also save this as DWG. So now I want to save this as a DWG, so I can open that with AutoCAD, and then I can customize that drawing and make any changes to it. So while that's loading, while I've saved that, let's have a now look at the report. So it's very important now for me to be able to get these numbers out of the design. So I'm looking for very simple reports. So it's very easy to use here. So these are the contents in my report, and I have several different levels of reports. So time now to generate my report and take a look at how those numbers and that information is presented. So I'm going to generate that report. So let's generate that report. So you can see it's being generated. I chose to generate this in Microsoft Word, so you can also generate it as a PDF. So now here is my report in Microsoft Word. And now at this point here, I can customize these calculations. Fully customizable. Yeah, I can change the font, change the layout, add additional calculations and numbers in as well. It's very easily presented in tabular format. So this is a very concise report. If I wanted to, I could generate a more complex report with all the references to the Eurocodes as well. So it's very easy for independent checker. Then now I'm interested in having a look at that drawing in AutoCAD. So I'm nearing the end of my journey here with this column. I want to see what that AutoCAD drawing looks like. So here's my drawing in AutoCAD. So you can see that information is being carried across through to a DWG. I can now make changes to my column here if I want. So I've got my total weight there as well, my assumptions there, and my bar schedule. Okay, so ideally I'd like to put this bar schedule on a separate sheet, so I can add a layout for that and just arrange the bar schedule and the viewports for that. So now back over to the main model. So now from here you can see that once I'm happy with my design, I can choose to click and update. Okay, so from clicking and updating all, that will allow me then to update everything. Okay, and at the same time I can open other members as well from the design library here. So I can switch from that column to, say, a slab. Here I have an example of a slab. So the slab module is relatively new here. So we've just extended the abilities here. And I can go back to that beam. So what I'll do now is I'll show you an example of a slab on a more simpler model. So that's just a little bit of a better model I'd like to show you one. So I'll close and update all. I can update all the sections here. So we'll now make sure that that column which I've designed, it will update the reinforcement settings for that. So if I were to have a look at the results here at this point, the provided reinforcement, you'll see the new results. So over to the slab which I mentioned. Okay, so now here is a very simple structure. Over into my analysis model. Okay, let's just change this view and turn off the mesh. Okay, now let's open this with the design modules. Excellent. So I'm greeted by two views here, a plan view and a 3D view. So I want to have a look at the reinforcement diagram. So I have reinforcement diagrams, reinforcement cage, and then a combination of the two. So at the moment, I haven't generated any reinforcement, so that's why I could see anything for reinforcement cage. Here I would like to show you there's two methods, so FEM or strips. I usually like to design using the strips-based method, so I'm sure some of you prefer that. So let's go with the strip method to find this a quicker way, or sometimes a simpler approach to the design. I have a series of strips already generated there previously, so I've cleared my strips now, and you can see here I've got a set of results, so represented by the isolines. I'm looking at dead load at the moment, so let's look at ULS combination 108. Let's choose that and have a look at some of the forces here I'm designing against. Let's switch just the major direction, so we'll generate our strips here. So that's the forces, Fxx. From the geometry, here I have all my geometry, and I can add in openings to the slab as well. So the slab openings, if I have any openings which are in my original Revit model, they will be carried through to this. You can then add in additional openings as well and send it back over to Revit for that detailing. So there's my reinforcement diameters, reinforcement settings. So I've chosen strip base. For the solutions, top and bottom, I can choose minimum coverage. So I can change that to 80 if I wanted as a minimum. And for the second layer, it's only 30. So we don't really want to go over that. Parameters, minimum diameter, I'll just increase to 10. And the maximum will go up to, say, 16s. Okay, so that's been carried through to the top and bottom in both directions. Let's apply it, and now move my way across the. Now we can look at the generating the strips. So I can either add a strip in manually. So here I'm going to draw a generator strip from end to end in the major direction. Okay. There we are. I've just simply created a strip here. Also, it has a predefined width, which you can change. Here I've just dragged that out further to widen that strip, and now let's see what the moments look like on that strip. So now I can very easily spell out each of the type of forces for that particular strip, see what they look like. And that's in general. And the other option I have is I can clear that and I can generate an automatic set of strips. So if I select all, I've selected all strips in both directions, so it's generated a series of strips in both the major and minor direction, in both the major and the minor directions. So here we have the strips in both directions. So let's just split that down to major and minor. So these are a little bit wider than what I provided originally for that example I showed you. I can also change the width of these. If I wanted, I can narrow one of these down and add an additional strip in between as well. Okay, so there's my strip generation there. And now I'm ready to calculate this slab. So let's calculate this and see what sort of reinforcement cage that returns us. So I'm expecting to see some reinforcement diagrams here. So here is the provided against required AS for each of those strips. And if I switch to a singular view, so strip 1, okay, in the minor direction, here we can see provided against required. Switch to another strip, so strip 3. Okay, so there we can see what that looks like. And I also have an option to look at delta, so the difference in reinforcement, how much additional or how much over I provided, how much I've gone over the provided, the required. So the difference between provided and the required. So nothing there. Reinforcement zones. So I now have a series of reinforcement zones. So I'm looking at the minor direction there. Here's the major direction. And I can see the layout of the rebar there. And I can add in at this point, add in a series of bars, individual zones for the bars. Okay, so if I have any peak areas which I need to cover, I can add in an additional area with reinforcement to cover that. So in the model, now I have a lovely cage, reinforcement cage that I can look at arrangement. It's very nice to see this being generated, to see how everything is arranged. So we've got some additional bars there for that area. Very nice. Right, so let's look at this edge here. Okay, so here we've got some warnings as well. So it's saying that, just look at this view first and I'll show you the warnings, the plan view. So over in that warning section, you can see that some of the bottom reinforcement is not enough to cover the imposed reinforcement. So you can see what that looks like. Yeah, so if I wanted to, I could go back into that the reinforcement, into those strips, rather all the settings. So I can go either add in an additional strip, or if I go add in a layer of additional bars. Equally, I can go into the reinforcement settings here, and where I had a minimum and maximum diameter, I can increase the diameter of those bars as well. And then I've also got the option for the coverage as well. Where I had area of coverage, I could increase that as well. There's a lot of things I could do here. I could bring them in at closer centers, obviously increase now the diameter of my bars, add in additional bars over that area, localized area, if it is a case of that. So I've just increased the diameter here. I'm still thinking I'll probably see that, yeah, I still need to revisit that just to bring that up to scratch, make sure I've got enough reinforcement in the bottom. So very easy to amend your design, and you know exactly what to do through those warnings there. So over the interactive drawing now. Again, this is very similar to the column I was looking at. So I've got two sheets here in this case, because I have top and bottom reinforcement, namely. I'm just going to increase the scale of this so I can zoom in and see a little bit better the number of bars and the range which they apply to. So we have, there we go, 10mm diameter bars, 250 centers in that range. So a few clashes there. Okay. And the bar schedules, we've got two bar schedules there. Right, so back over to the sheet, and let's save this as a DWG. So I'm nearing the end of this journey here, so time to save this as a DWG. Let's save that there. Again, the report is very similar to the columns as well. So in this case, the slab report is usually a lot simpler, okay, depending on what you choose. So if it was a FEM-based method, you probably have a little bit of a more complicated report, more information there, but we've gone for strip space, so it'll probably show me a summary of the strips and the reinforcement in those strips there. So here's my report. It's only about 7 pages long, so you can see my strips in both directions, materials, concrete covers, and the warnings and errors which I need to correct. So hopefully that drawing should have loaded by now in the Autocode. If not, let's just open it up again. Okay, there we go. Let's pan in, and here is my drawing in AutoCAD. Okay, so I'm ready to make changes to this drawing in AutoCAD and customize it, adapt it to what I need. So equally, what I can do now at this point is close and update with this reinforcement. Okay, so I can go to close all and update. It will update that slab and it will carry it through to the main model. From that point, I can then send that across, export that to Revit. Okay, so I'll export that as a GTCX for detailing in Revit. So through our Power Pack, you've got that bidirectional link. Yeah? So you've got the same basic design tools there as well, but you've got a set of additional detailing tools with that Power Pack in Revit. So that my technician or I can then amend those reinforcement cages that we saw. They will be carried through. I can amend that in Revit, refine that, refine and change those design reinforcement cages to what I need. Okay, so that brings me then to the end of the demonstration in advanced design. I'll now open up the Q&A session for you guys to ask any questions that you have related to what I've shown today, or it can be anything in general related to structural design or advanced design or even Revit. So I'd like to say thank you to everyone who's attended today, and I look forward to picking up any questions that you may have for now. Thank you and bye for now.